Welcome to Graphing Quadratic Functions. The best way to use this video is to take notes while I'm teaching, pausing the video whenever necessary, and every time we arrive at a U-try, pause the video, attempt the problem, and then press play when you're ready to see the solution and the work. These are the topics we'll be covering in this section. We'll start with some quadratic vocabulary. So in this section, we're going to talk about vertex. The vertex can be also a minimum if it's the bottom of a parabola, or a maximum if it's at the top of the parabola. We've got the axis of symmetry runs right through the parabola's vertex. And if you look carefully, that's where you would fold the quadratic over and it would be a perfect mirror. Our y-intercept is the point on the graph where it hits the y-axis. And the x-intercept can also be called zeros or roots. Those will be where it hits on the x-axis. We'll deal with those later when we start solving. So example 1, determine the vertex, axis of symmetry, zeros, and y-intercept of the parabola. So we'll start with vertex. The vertex is the lowest point or the highest point, and this would be the ordered pair 3, 1. The axis of symmetry goes right through, it's the vertical line that goes through, and that is always x equals, and in this case, the x value is 3. The zeros, this graph does not hit the x-axis, so there are no real zeros. And the y-intercept is where it hits the y-axis. That's going to be 0, 7. All right, we're going to start by graphing standard form quadratic functions. So there's a relationship between the standard form quadratic function, which is right here, and what we know about this function. So we can learn about the shape of this function by looking at the leading coefficient a. If our a is positive, our parabola will go up. If our a is negative, our parabola will go down. All right, so let's talk about the axis of symmetry. When we're given a standard form function, we have to use this formula here to find the axis of symmetry. X is equal to the opposite of b over 2a. Then to find the vertex, we plug this value of x into the function, and that'll give us the y value of the vertex. We can also find the y-intercept pretty easily. The y-intercept is the constant value at the end of the function. We'll talk about x-intercepts and zeros later. Okay, let's start graphing. Determine the shape of the parabola, the y-intercept, the axis of symmetry, and the vertex for this equation. Then sketch the graph. You need at least 3 points. So based on, I'm going to put a 1 there, the a value, our shape is going to be going up. The y-intercept comes from our constant here. Standard form, you can always find the y-intercept pretty quickly, but the axis of symmetry is what requires work. So the axis of symmetry is always x equals the opposite of b, so the opposite of b, a, b, c, over 2 times a. So that's going to give us -2. The vertex is always that x value, but we plug it in. So it would be y equals -2 squared. Make sure you use that parenthesis, otherwise you will get the wrong answer. -2 squared, and you should get -1. There's a couple ways to graph, but we're going to use our vertex, -2, -1, and we're going to graph that axis of symmetry. And we've got our y-intercept of 0, 3. Now here's the cool thing. Once we have our axis of symmetry, we can use mirroring to graph the other point. So we know that this is 2 away from the axis of symmetry. So there's going to be a point 2 away right there. And we have connecting it with a parabola. All right, let's move on to example 3. Let's get rid of some of that stuff. Sorry about that. Okay, we're going to determine the shape of the parabola, the y-intercept, the axis of symmetry, and the vertex. So our a value here is negative, so our shape is going to be going down. Our y-intercept is the c value, so 0 equals -5. And the axis of symmetry is what requires a little bit more work here. It's going to be the formula opposite of b over 2a. So we're going to end up getting -2 over -4, or +1/2. To find the vertex, we take that x value and we plug it in for all the x's to get our y value. So y equals -2, 1/2 to the second power, plus 2 times 1/2, minus 5. Go ahead and type that into your calculator. You should get -9 over 2. So for graphing purposes, I like to change these into decimals. And then we're going to graph +0.5, -4.5. So it's going to give us right there. And then we're going to graph the y-intercept, I'll use a different color, is 0, -5. And let's not forget to graph our axis of symmetry through that vertex, because that's going to help us get that third point. So this point is about half away, so there's going to be a point half away there, and that is our parabola. You try on this screen, press play when you're ready to see the solution. Moving along to vertex form. So we were just with standard form. With standard form, you can easily find the y-intercept, but you have to use the vertex formula. With vertex form, you can easily find the vertex, but you have to do a little work for the y-intercept. So here is vertex form. The a value determines the shape again, and this time the axis of symmetry is h. So sometimes, since this is -h, I like to think of it as the opposite of that inner number. And the vertex is the opposite of that inner number and exactly that outer number, hk. And the y-intercept, unfortunately, you have to plug in 0 for x and solve. It is not k. And the x-intercepts, we'll talk about that a little bit later. So let's go ahead and give this a try. Determine the shape of the parabola, the y-intercept, the axis of symmetry, and the vertex of this equation. Then sketch the graph. Remember that we need at least 3 points. So we'll start with the shape. There is no number out front, so that's a +1. The y-intercept takes a little bit of work. So the y-intercept is when x is 0. So we'll plug that in. So f of x, or f of 0, is equal to 0 minus 4 squared minus 1. Don't drop that negative when you type it into your calculator. You end up getting a really big number here. We've got our y-intercept is 0.15. I'm not really sure how I'm going to graph that, but we'll come to that in a minute. So we've got the parabola, the y-intercept, the axis of symmetry is always the opposite of that inner number, so it's +4. And our vertex is the opposite of the inner number and that outer number. All right, so now we have to sketch the graph. So I am definitely okay with graphing this vertex and my axis of symmetry, but I am not going to graph that y-intercept. So another way to graph, if you don't like your y-intercept, is to pick points on either side of your vertex so you can get 1 point and then mirror it. So let's go ahead and plug in x equals 3. So that would be f of 3 would be 3 minus 4 squared minus 1. So we'd get -1 squared minus 1. We get 1 minus 1 is 0. So that's this ordered pair. And then we can mirror it to the other side. And now we've got our 3 points to graph. All right, you guys are going to give this next one a try. There are 3 problems here. Press play when you're ready to see the solution. The answer to the first one. And the answer to the last 2. That concludes graphing quadratic functions.